Hello and welcome to this video. My name is David Thorne. This is now the second video or lesson in my Python sets for beginners tutorial. And in this one we're going to do a deeper understanding of sets. Now if you haven't watched the last one, we went through kind of as many topics as possible about creating sets and using sets. But this one we're going to dig a little bit deeper. So without any further ado, let's get started. So first thing is checking if a set is a subset of another set. Okay, and this is where it could get a little bit confusing, is that set 1 has 1, 2 and 3 in it, right? And set 2 has 1, 2, 3, 4 and 5 in it. Now we can see here that set 2 contains 1, 2 and 3, all right? So but set 1 doesn't contain 4 and 5. So it could be that set 2 is the main set and that set 1 is then like a child set. It's just a snippet of set 2. And this is what we generally call as a subset, all right? So we're saying is subset 1, or is set 1, sorry, is it a subset of set 2? Well, yes it is, because this contains all of the numbers, right, from 1 through to 5. And set 1 contains 3 of those objects, let's call them, within set 2. So it is a subset. Now, if we look at the next example on 13, we see 6, 7, 8. Now, set 2 doesn't contain 6, 7, 8. So it cannot be a subset of it. And this would then return false. Now the next one, 1, 2 and 5, right, on line 14, 1, 2 and 5. We can see here that set 2 does contain the number 1, does contain the number 2, and does contain the number 5. Remember, sets are unordered. It doesn't matter about which order it is. It's just saying, hey, does set 2 contain these 3 objects? And yes, it does. And then finally, we've got 3, 4, and 6. So this is like saying, hey, set 2, as in object 1, 2, 3, 4, and 5, do you contain the number 3? Yes. Do you contain the number 4? Yes. Do you contain the number 6? No. So at any one point where it says no, I don't contain any of those items, it cannot be a subset of that. Now, it could be that 6 was contained in a different subset, right? And that came, but that's not the point here. The point here is that this has to the set 2 here, I don't want to say the word, has to contain all of the elements in order for this to be a subset, all right? And so it's like the parent has to contain all of the child items for another set to be a subset, right? Sub means it's less than, it's lower than, all right? Anyway, let's continue on to the next example. Oh, look. We're on superset now. So now we've got set 1 is kind of reversed. 1, 2, 3, 4, and 5. And set 2 is 1, 2, and 3. So we already know from the last example that set 2 is now a subset of set 1 because it has a snippet of set 1. So by saying set 1 is a superset of 2, that's correct because set 1 contains all of the items and more than set 2. Set 2 doesn't care about some of the items in it, but it means that it is a subset of set 1. So that makes set 1 a superset, right, of set 2. Now we can see here, so we're looking at 1, 2, 4, and 5. Well, 1, 2, 4, and 5, they are all elements of set 1. And I've added that key word here, right? They're all elements. They are all objects in itself, but in set terminology, they're all elements in a set, and 1, 2, 4, and 5 are all elements contained within inside of set 1. So that is a subset of set 1, which means that set is a superset of set 2. Well, no, that's not true, because 1, 2, 4, and 5, yes, it's a subset of set 1, but it doesn't contain 3. So this doesn't contain 3, which doesn't make it a superset of set 2. Now, if we do 1, 2, 4, and 5 once again, and we say, is it a superset of 1 and 2? Well, yes, because this one set contains, this one set, first of all, is a subset of set 1, right? And 1 and 2 is a subset of this one here. So that makes 1, 2, 4, and 5 a superset of 1 and 2, all right? And yeah, okay, let's go on to the next example. Converting a list to a set. Now remember, a list is not a set. This is what's really important to understand, is that we have a list here of 1, 2, 2, 3, 3, and 4. There's duplicate items in this, but the second we pump it into a set function, we now know that it's going to remove all duplicates, and because all items have to be distinct. And it doesn't have to be in this order. Just because we gave it in this order here, it could be in any random order. Sets are random. They are not ordered. That's why it's called an unordered list or unordered set. So let's go to 4 now, and the set length. And we can do this quite easily using the length function from Python and just say, hey, how many elements are there in this one set? And in this case, there's 1, 2, 3, 4, and 5 elements, but this could go on to as big as you want. This is nothing more than a quick version or a very efficient version of iterating through my set and always incrementing a value like x is equal to 0 in the beginning, and then every item you go through, element you go through, x plus plus, and it updates it, and it will output 5. So this is the quick way to know how many items in a set. Now obviously, to go back to subset and superset, is that if my set has 7 items in it, right, 7 elements in it, and my parents' set has 5 elements, right, then my set cannot be a subset of my parents' set because it's got more elements, which means that my parents' set cannot be a superset of my set because it's got less amount of elements. So in order for a subset, in order for a set to be a superset of a subset, it has to contain the exact amount of elements in the subset or more, all right? So it's another way of indicating whether or not you are working with a subset or superset of something, because they have to have the same length or more to be a superset, all right? And to be a subset, you have to contain the same amount of, well, if you contain the same amount of elements as another element, that means you are equal, they're the same set. So a subset will contain less than the amount of elements in the superset, all right? Anyway, going too far. So now clearing a set. And at the moment we have a set with 5 elements inside of it. And by calling the clear function, this is an impure function. So it means it's going to modify this one set in place, in line. All right. And so when we come here and we output it, it's just going to be an empty set now. It's not going to contain any items whatsoever. So the length is also going to be 0. Let's go to the next one, set pop operation. Now, this is a little bit of a red herring, all right? Because yes, sets have the pop function, but they do not work. And I'm going to repeat it again. They do not work in the same way as the lists do. They do remove and return the last element from the list, right? But that element could be any of the items in the list at any different time. So it really doesn't matter whether it's the last item on the list, because there's no ordering of the items. So it doesn't really know which one's the first one, which one's the last one. All right. So this is a way of getting randomness from randomness. Okay. But just because it pops one off every single time, right, doesn't mean to say it's going to guarantee that this is always going to happen on every single Python environment or installation and so on. You should always use a list if you want deterministicness from a list. All right, don't use sets for deterministicness. Anyway, you'll see that it'll primarily be 1 nearly all the time here because it's the first item on the list. But anyway, let's go to the next one. So now copying a set. Declared set, I've done it in the beginning to say this is now a set containing the elements of 1, 2, 3, 4, and 5. And then I've made a kind of like a copy of it to say original sets. These two are equal to each other. All right, this is what I want to show you. Now, copied set is saying take the original set and we're going to now call copy on it. And this is going to make a hard copy of it. So copied set and original set are two separate sets. They contain exactly the same item. So it's not a subset of the set. They are two separate sets, but they are identical at the copy, right? But then we say copied set add 6, right? This would mean now that copied set has one more item in the set. So it potentially would mean that declared set and original set is now a subset of the copied set, because copied set now has one more element and it contains all of the items in original set. Now, if we say original set pop, this is going to pop an item off the original set and the declared set as well, because it's not a hard copy. And if we then print it out, we see declared set is going to be 2, 3, 4, 5, and so on. And then original set, because it literally is just a copy of it. It's not a hard copy. It's the same thing. It's going to be that here. And we now know that copied set, we added 6 to the end of it. So it's there. Okay. So this is how you copy a set. Now you could do a for loop, but this is basically doing the for loop for you. It's super, super easy. All right. Let's go to the next example. Now, frozen set is like the absolute reverse of this. So to say frozen set says, hey, you can't add stuff to me, and you can't discard things from me. You can't update me. You cannot change me. All right. And if we now look at frozen set, you'll see it can do a copy. That's fine. It has difference and all the other functions there that set has, but it doesn't have the other functions that set has. And if we come here, you'll see set has add, discard, and then remove. All right, and frozen set doesn't have these. So your way of getting an immutable set, and if we output it, you'll see this is here. All right, so it's the same as a set, but it just doesn't have all of those mutable functions, all right, that set has. And now number 9. So set intersection update. So we now have two sets, 1, 2, 3, 4, and 3, 4, 5, 6. We can see that set 1 and 2 intersect at 3 and 4. All right, so we know that if we say set intersection, then we know that we're going to get 3 and 4 outputted, all right, because that's what they are. And if we just output them in the beginning, we get 1, 2, 3, 4, and 3, 4, 5, 6 here, all right. And now if we still output set 1 here, so we're printing, this is the first print, this is then the second print to say set 1 intersection. So this is then, set 1 here is 13, it goes to 20 here. But then when we say set 1 intersection underscore update set 2, what this is saying is, hey, give me the intersection of set 1 and set 2, and now update, in other words, remove all other items that don't intersect with both sets, all right? And then we print it out, we see now that we get that the set has been modified to become just have 2 elements in it. So it's sometimes important to make sure that you do a copy beforehand. And in the next example, this is exactly what I've done. So we've got set 1 and 2, and they intersect once again at 3 and 4, all right? But this time we've made a backup set using set 1 copy. So we've always got a copy of it, and we print out set 1, and then we can do set difference to set 2, and we get then the difference between it. And then we've got difference update once again, and we then can see here that set 1 has been modified, right, to the difference of the 2. And we see that they intersect at 3 and 4, and the difference of set 2 and 1 is that set 2 doesn't have items 1 and 2 in it, all right? So this is now how this is now the difference between the difference function and also the difference underscore update function, all right? And I'm just introducing you into, if you need a copy of the original, then I would suggest you make a backup copy of it in the beginning to be able to access it. Anyway, whoa, dear, that's now a good, deeper understanding of sets. And if you are still watching this video right now, well done. Because I think I'd have probably nodded off a little bit. Anyway, sets are super important, and the fact that you have a fundamental understanding of sets is really, really good. But just remember that there is always documentation for you to read, and you don't have to remember the smallest details of things. And when you need distinctness between items, right, or you want to be able to know the intersection or the union of different sets for some reason because you're working with lots of data, then sets are the best way to go about. Lists are not, because you're going to add so much more work to be able to filter stuff down. That's why you use sets instead. And that's why sets come with a few other different rules and also advantages. Okay, with that said, thank you very much for watching. There is still one more video to come, and I'm going to make it after making this one. But thank you very much for watching. Don't forget to give me a like and subscribe if you want to get notified when I update or I create any new videos. But otherwise, liking the video or commenting really does help the YouTube algorithm to allow other people to find this content. It doesn't bother me, right? It's there to help people like yourself and others to find this content. And if you like my content, then maybe they will like it as well, or maybe they would feel that it's beneficial to watch this video too. With that said, thank you very much for watching. I will see you in the next video, which is going to be on the screen right about now. Thanks then. Ciao, ciao. Goodbye.